Hey everyone, this is our review of the rational arithmetic standard. That's our standard there. This one is good to do first because it covers some basics that you'll be doing later on when we work with rational functions and their graphs. So let's jump right in. When we talk about arithmetic, we're talking about add, subtract, multiply, and divide. So those are the four operations we need to be able to do with these, which are rational functions, because they have a division. They're being divided. Alright, so let's jump right in with the first one. F of x divided by g of x. Well, if I want to put f of x, I'm going to start by just writing my problem. F of x is equal to x plus 1 over x squared minus 4. And I'm divided by g, which is x plus 3 all over x. Alright, so maybe you remember when you're dividing fractions, or when we're dividing, we had a couple options. We could either say we keep, change, and flip. That was an option. Or I think more mathematically correct would be to say we multiply by the reciprocal instead of dividing by. So here we're trying to divide by g of x. So instead we want to multiply by the reciprocal of g of x. So I'm going to rewrite the problem below. I'm going to keep my f of x like it is. And then I'm going to turn my g of x into a multiply, and I'm going to flip it. Instead of it being x plus 3 over x, it is now x over x plus 3. Awesome. Then when we're multiplying, we'll see this in the next example, we just multiply our fractions straight across. So we end up with x plus 1 times x on top. I added parentheses to make sure they're separate, and we remember that if we did multiply them through, we're going to have to distribute. And then on bottom we have x squared minus 4 times x plus 3. Cool. So you could leave it like this. I'm going to give us two different forms. In blue, I'm going to put a factored form. Later on, it'll be useful to see stuff in factored form. I'm also going to put a form in green over here, which is standard form. So these are our two options for recording our answers. We've done our work. We said write as a rational expression with a single denominator. We've done that, and so we're actually done with this problem. I just want to show us that if we did go forward to rewrite it a different way, there are two ways. So if I did it factored, my top is already factored, x plus 1 and x, so that looks good. There's no way I can pull common terms out of them. There's no x squareds. On bottom, the only thing I see that I can factor is this x squared. To me, looks to me like a difference of squares, or we could treat it as a quadratic. So I have two x factors, x and x. I need things that multiply to negative 4 and add to 0, because there's no x term, so it's negative 2 and positive 2. Or maybe you recognize that pattern as the difference of squares. So that would be how you could write it as factored form. If you wanted to write it in standard form, I would just instead do all the multiplications out. So on top, I'd be left with x squared plus 1 times x is x. On bottom, x to the third is my largest power. Second largest is going to be 3x squared, I believe. Yep. And then minus 4x. And then minus 12. Negative 4 and 3 is 12. So making sure to distribute. So any three of these, the red, blue, or green answers are great for this problem. Later on, we'll see the factored versus standard will be useful when we are, here's our standard over here. It'll be useful when we're talking about graphs. Awesome. So let's go to B. F of x times g of x. Again, I'm just going to start by writing the problem. I added parentheses there because I know I'm going to need them later. And then this g of x is x plus 3 over x. Great. Like we just did before, to multiply, I slide them together straight across. So it would be x plus 1 times x plus 3 all over our x squared minus 4 times x. So very similar to division, except we don't have to take a reciprocal, we just multiply straight across. Again, I'm going to show us our factored version. The top is factored. Nothing else in common between those, no extra terms I can factor out. On bottom, again, I can factor that as a difference of squares. and then I have an x as well. X. If I wanted to write it as standard form, I'd have to distribute my top. So 4 terms here, x squared plus, I know there's going to be a 3x and a 1x, and then a 3 at the end. And then if I were to combine them, that's just going to turn into a plus 4x plus 3. So you could write that in 2 steps. And then on the bottom, I have to distribute my x through x to the third minus 4x. Great. So these two are pretty straightforward. We have both factored and standard form. Let's move on to addition and subtraction. These two are very similar. So I'm going to start by just writing my problems, and I'm going to leave myself some space because we're going to manipulate these. So I'm going to go that. That's my f of x plus my g of x is x plus 3. Oops, not that much space. X plus 3 all over x. I think? Yes. All right. So here I could try and combine these, but then I see to myself, I can't add fractions that are unlike. These two have different denominators. They're different types of fractions. Right now I can't combine them because they're different. So I need to make a common denominator. That's what's important for both of these. Addition and subtraction is a common denominator. And if we remember, the only denominator. The most important thing we can do to adjust these fractions is to multiply top and bottom. So I could multiply over here by x and x. Again, adding parentheses to make sure I keep track. And then I can multiply on the right by x squared minus 4. Again, adding parentheses so that I don't forget to distribute. Cool. So now, by multiplying by the other denominator, I should have a common denominator. Let's check and make sure. Over here, my denominator is x times x squared minus 4. Over here is x times x squared minus 4. Great. And I didn't change anything. I didn't change the quantity because in every case, I multiplied by something over itself, which is just the same as multiplying by 1, which doesn't change my value. So those are just good checks to have in mind. All right, so now we've made a common denominator. Now again, we could write this in standard form, we could write this in factored form. For simplicity, because I trust that you guys can distribute and write in standard form, I'm just going to leave this in factored form so that we don't have the videos get too long. X plus 3. And then I'm going to write, I could write this factored, I'm just going to leave it as is, to be honest. And that's all over x times x squared minus 4. Again, if you wanted to multiply this all out, combine like terms, you could, but we don't need to for the purpose of this question. It's just said write as a rational expression with one denominator. We've done that. Check. All right. Subtraction is going to be pretty much exactly the same thing. In fact, I'm going to see if I can do something sneaky here and just copy this. That's pretty slick. Subtraction is going to be the same thing, except it's just a subtraction sign in the middle. So we'd start with the problem like we had it in the red. I would add the common denominators, multiply, and then just instead of adding, I would then subtract. So x times x plus 1 minus x plus 3, x squared minus 4, all over our common denominator. Since we have a little time here before the end, I'm going to just multiply this through to show us how we could. This will leave us with x squared plus x, so I'm just going to replace it. X squared plus x. Over here, this is going to give me a bunch of terms. It's going to give me x to the third